Hi everyone, this video is the solution to example 2 on the topic of unit load method. In this case we have a cantilever with a UDL and a point load, and in this case we have numbers, so we're not going to be solving for generic loads, but the rigidity of the beam is going to still be EI, so it's going to be still generic. In this case we want to find out the vertical displacement at the free edge, so we're trying to find this displacement here, delta. So similar to the previous case, we need to split this into the real and the virtual structure. The first thing is to define the real one as the exact structure that we are presented with. So UDL of 3 and then a point load of 24. And now the virtual structure has nothing more than 1 kilonewton at the end of the beam. So now we can calculate the bending moment diagram, and considering that both of these have 6 meters, the moment we see here on the left is going to be 24 times 6 plus 3 times 6 times 3, and that is equal to 198. So we know that this bending moment is nothing more than a parabola like this with 198 tension on the top. Regarding the other bending moment diagram, is going to be nothing more than a triangle. So here we have reaction of 6, so this value here is going to be 6, so we are ready to get our displacement. So if we now use the equation from the principle of virtual work, we can get that delta is nothing more than a parabola times a triangle divided by EI. So now we could go into the table and apply this table and get the right answer straight away. But if we do it the way we set up this problem, we won't get the right answer. And I'll try to explain to you why. Because this parabola here, this parabola that is defined by that 198, is not a pure parabola that is described here in this picture. So if you want to use this table, if you want to do the parabola times the triangle, you need this parabola here to be defined only by the UDL. So what we have to do in this case is to separate this diagram into two ones. We need to separate this diagram into one that comes from the UDL plus one that comes from the point load. And the way we do this is to say that the one to the point load is going to be a triangle with 24 times 6 as the moment, which is 144, plus another one that is parabolic, and the moment here is going to be the 3 times 6 times 3, which is equal to 54. So now, if we're interested in finding out this displacement delta and using the table to do this correctly, now we're going to say that delta is going to be the parabola that we see times the triangle divided by EI, but now we add the other triangle times this triangle. So we're going to do this one first, and then this one second. Okay? And only in this case we're going to get the right answer. So let's divide this by EI as well. So our solution at the end is going to be 1 over EI. And now, parabola times triangle will be 1 over 4 ACL plus, and now triangle times triangle. And here we need to make sure the triangles are growing in the same direction. So we get 1 over 3 ACL. And this is it. Now we replace, and we should get the right answer straight away. So 1 over EI, 1 over 4. Now we're going to do the parabola first, so that's 54 times 6, and now the length of these triangles is 6 as well, plus 1 over 3 times 144 times 6 times 6. Now all these values are positive because the triangles are all drawn in the same side. So because all of this is tension on the top, when we multiply the two diagrams, we're going to get always a positive answer. So at the end, we solve for this. We should get 2214 divided by ER. The fact that it's positive means the displacement is down, and this concludes the problem. Thank you for watching and have a nice day.